Okay, so this is tests for parallelograms. Remember to spell that correctly. Tests for parallelograms. Okay, and the question they're trying to answer is what ensures that a quadrilateral remember, quadrilateral is a four-sided figure, is a parallelogram. Well, there's more than one thing. Okay, and the author goes through these in the form of theorems, and I'm kind of giving you the abbreviation for the theorem. Theorem 6.9 says if both pairs of opposite sides are congruent, use the symbol for congruent, then the quadrilateral is, and just use the symbol for parallelogram. Okay, and you may want to do this on the parallelogram if both pairs of opposite sides are congruent. So if we mark these two congruent and these two congruent, then yes, it is a parallelogram. Okay, and then theorem 6.10. Okay, and this also ensures that it is a parallelogram. If both pairs of opposite angles, okay, if both pairs of opposite, and you can use the symbol for angles, if both pairs of opposite angles are congruent, okay, then the quadrilateral is a parallelogram. Okay, and what that's going to look like. Okay, and mark opposite angles. So this angle would be congruent to this angle, and this one would be congruent to this one. If that's true, then your quadrilateral is a parallelogram. Okay, then theorem 6.11 is another way to tell. If the diagonals bisect each other, then let's just abbreviate it. The quadrilateral. Let's just abbreviate quadrilateral. You know what it is now. Is a parallelogram. Okay, and for the bisect, draw the diagonals, and it would end up that this would be congruent to this from the center to the, and this one would be congruent to this one. Okay, they bisect each other. Okay, and you can, change it like that too. I mean, you can change the length of those. This would be congruent to this, and this would be congruent to this. Okay, they bisect each other. Then it is a parallelogram. Okay. Okay. Last one. Theorem 6.12. If one pair of opposite sides is parallel, You can use the symbol for parallel and congruent. And that's an and statement. So both parts have to be true. Then the quadrilateral is a parallelogram. Now I made a note from last year to emphasize it has to be the same pair. Okay, has to be parallel and congruent. So when you look at if this side is parallel to this side and this side's congruent to this side, it's not one side's parallel and the other side's congruent. It's got to be the same side. So you might make a note out here. It's got to be the same pair. Okay. Okay. Now let's look at a couple of examples. Okay. How they're going to use those. Say they ask you to find x and y so that each quadrilateral is a parallelogram. Okay, they want it so that each one is a parallelogram. So, example. Say I give you this side was 5y, this side was 2y plus 12, this side was 2x minus 5, and this side was 3x minus 18. Okay. Okay, take a minute. You agree? I get x equals 13, y equals 4. Okay? And that would make opposite sides congruent, so that's theorem 6.9. Okay? Look at another example. Say I give you this is 3x minus 17. That's that angle. This angle is y plus 58. This angle is 2x plus 24, and this angle is 5y minus 6. Okay, so which theorem? 6.10, right? If both pairs of opposite angles are congruent. So we want it so that this angle is congruent to this angle. So set it up that way. 3x minus 17 is congruent to 2x plus 24 and solve for x. And then mark this angle is congruent to this one. So set like y plus 58 equals 5y minus 6. Okay, solve both those. I usually, when there's an x on both sides, I usually subtract the smaller one and then take the other number to the other side. If there's no number in front of that y, it's understood to be a 1. Okay, I get x equals 41, y equals 16. You agree with that? Okay, check my arithmetic. Okay, that should be enough to get you started. Okay.